My name is Oveis Salehi, and this is the second video for ABG interpretation acid-base imbalances. I promised to solve some problems together, so we are doing so in this video, okay? So suppose pH is equal to 7.2 and CO2 is equal to 40 and HCO3 minus is equal to 12. Okay, so first of all, we need to know that what is the pH. So first look at a pH. It is less than 7.4. It is acidic. CO2 is normal, so we cannot interpret it now. Bicarbonate is 12, less than 24. So, as we said, bicarbonate is a base. So we have less bicarbonate, less base. What does it mean? It means acidic situation, okay? So it is acid. So we have metabolic acidosis at the first place. So this is acid and this is acid. So this is the culprit. This is the culprit. So we start from bicarbonate. So we have metabolic acidosis plus something. Maybe it is compensated, maybe it is whatever. So we need to calculate the number for CO2 to know that what is going on in the respiratory system. So in metabolic acidosis, our formula was this one, 1.5 bicarbonate plus 8. 1.5 plus, this is CO2, plus is equal to 1.5 bicarbonate was 12 plus 8. So it is equal to 26. It's 12, 8, 18, and 8, 26. So this is the number for CO2 that we expect the body to make it for full compensation. If the number for CO2 that we have in our patient, in our example, in our patient, is more than 26, it means that the respiratory system is retaining more CO2. So it is, if it is more than 26, so it is more CO2 that it should be. Okay, more CO2 than it should be. It means respiratory acidosis, because we said that CO2 is acid. More acid in the respiratory system equals to respiratory acidosis. If it is less than 26, for example, 15, 10, 2, 0, whatever, it means less CO2, it means less acid. What does it mean? Less acid? It means basic situation, it means alkalosis, so it means respiratory alkalosis. But, so this is what we can interpret. Look at the number that we have here. The number is 40. This is the normal number, but not in metabolic acidosis situation. The body is supposed to do something with metabolic acidosis. I said when we have more acid, we should make some bases or lose some acid, whatever, to compensate. It is 40. More than 26, it is 40. It is 40 in our patient, so we have respiratory acidosis. And in the first place, we had metabolic acidosis, and now we just proved that we have respiratory acidosis. So it is a mixed metabolic and respiratory acidosis. Okay, and the pH is low. Okay, this was the first example. The next example here is pH equal to 7.3, CO2 equal to 50, and bicarbonate equal to 50. Like other times, first go to the pH. pH is acidic because it is less than 7.4. CO2 normal is 40, now is 50. CO2 is acid, more acid than normal, so it is acidic situation. Bicarbonate is 50. Bicarbonate was a base, more base, so it is base, is basic situation. So the culprit is this one for this pH. I mean, the numbers are not real. Maybe it seems very derailed, but this is just an example to make. The pH is acidic and CO2 is retained, so we have, from the first place, we have respiratory acidosis plus something. Maybe it is compensated. Maybe it is compensated, so it is just simple respiratory acidosis, or whatever, or maybe it is some mixed problem. Okay, we have 10-point increase in CO2. 10-point increase in CO2. Increase in CO2. As we said, when we have increase in something in one character, we have to increase in another character. This is the compensation. This is the way compensation goes. So when we have 10-point increase in CO2, as we said in respiratory acidosis, just suppose that everything, every example here is chronic. So chronic respiratory, just suppose that is chronic because we don't have any history. Increase in 10-point CO2, 10-point CO2, and chronic is here. Okay, 4. Respiratory acidosis. Okay, so we have 10-point increase in CO2, means 4-point increase in bicarbonate. Normal bicarbonate was 24 plus 4 is equal to 28. If it is more than 28, now we are talking about bicarbonate. If it is more than 28, it means that we have more bicarbonate, more base. More base means alkalosis, means metabolic alkalosis. And if it is less bicarbonate, it means metabolic acidosis. Okay, because we are losing base here. When we lose base, we are in acidic situation, so it is metabolic acidosis if it is less than 28. Look at our number. Our number is 50. It is more than 28, so we have metabolic alkalosis also, and we had respiratory acidosis from first place plus metabolic alkalosis. So it is a mixed problem. So we solved this problem also. Okay, another example. pH equal to 7.6 and CO2 20 and bicarbonate equal to 15. So, as we said before, look at it. pH is base. No, I want to make it faster. Okay, it is base. CO2 is decreased, so we lost some acid. So decreasing acid is equal to base. Okay, we lost some acid, so it is base, is alkalosis. Here we lost some base, so it is acid. Okay, so the culprit is CO2 because it is base. It makes base situation. and the pH is basic. So we have respiratory alkalosis from the first place, respiratory alkalosis from the first place plus something. Maybe it is compensated plus nothing, or maybe it is some derailment that it has to be plus, that it has to be added on. Okay, so we have respiratory alkalosis. Go to the respiratory. As I said, just suppose that it's chronic. Respiratory alkalosis is here. So 4 point for each 10-point decrease or increase. Okay. So when we have 20-point decrease in CO2, we have some point decrease in bicarbonate. Okay. So when we have 20-point decrease in CO2, we have some point decrease in bicarbonate. 20 is 2 times 10, and now we have 4 times 2, because it's 4. 4 times 2, it is 8, is equal to 8. So 8-point decrease in HCO3 minus. The normal number for HCO3 was 24 minus 8 is equal to 1816. So, as we said, if it is more, if it is less, if it is more bicarbonate, it is about bicarbonate. If it is more bicarbonate, it means more base. It means more base. If it is more base, it is metabolic alkalosis. If it is less base, it is metabolic acidosis. Now it is 16. Go back to our number. Now our number is 15. Please don't be picky on 1 or 2 points in these kind of situations for ABG stuff. Okay, because in our memory tools and everything, we just ignored one or two numbers, 1 or 2 points. Okay, just ignore. Don't be picky on 1 or 2 numbers. If they want to make any patient in any diagnosis, they have to give more. They have to give more differences. Okay. Just don't be picky. If it is 16 and our patient is 15, it is fully compensated. So it is only respiratory alkalosis, which is fully compensated. Okay, so we've just done this one as well. And please give me your feedback, and if you need some more examples, just tell me. If it is not useful, just tell me. Not to do anything not useful. Okay, just tell me if you need something else or whatever. Thank you. The last example is pH equal to 7.2 and CO2 is equal to 60. HCO3 minus is equal to 32. Look at a pH. pH is acidic, acid. CO2 is acid, increased, so we have acid here. And base is increased, so we have base here. So the culprit is CO2, so we have respiratory acidosis, plus something, okay, plus something. Now the CO2 is, as I said, in our examples, it is chronic. Suppose that it's chronic. So we have 20 point increase in CO2. So some point increasing HCO3 minus bicarbonate. So 20 point increase in CO2. Respiratory acidosis is here. Chronic respiratory acidosis is 4. 2 times 4 is 8. 8 point increase in bicarbonate. So we have normal bicarbonate was 24 plus 8 is 32. Now we have in our patient we have bicarbonate which is equal to 32, so it is fully compensated respiratory acidosis. So I hope it was useful for you. If you have any question,